Hello everyone and welcome to Van Tech Corner. In this video, I'm going to replace my ISP provided ONT with a high quality XRP GPON module from LeoLabs, the LEOX LXT-010S-H. So in order to use the 2.5 XRP module, I will need another media converter. So you may ask me why you want to change from the ISP provided device to a high quality or to a third-party provided device. Well, currently I'm using a gigabit internet plan. However, the throughput that I got doesn't meet my demands, and sometimes we have some problem with the connection. That's why I have been playing around with different types of ONT, XRP GPON module and things like that. Recently, a customer service specialist from LeoLabs, Bartos, contacted me and introduced the new ONT that they make. It is the ONT and also the XRP GPON module. So I'm very interested on those devices, so I take a look at the website, read through their story coming from the ISP to be a vendor for ONT and XRP module. And I see that this is very interesting, so yes, I want to try the new device. So today I got on my hand this GPON XRP module. It is a gigabit and also 2.5 gigabit GPON module, so it should work well with your ISP. And beside that, this module is based on the Realtek SDK. Therefore, the customized interface and the web UI and the thing like that you can base on a lot of documentation on the internet. Alright, so before we proceed with the replacement, let's check out my current setup first, and then we're going to have some speed tests as well as a CPU overview before we switch to the new platform. Alright, so this is the NanoPi R6S. It is a 2.5 capable device. So right now you can see that my ISP run PPOE connection with no VLAN, because actually the VLANs already tagged from the OLT or either the ONT side. So in order to access the ONT, I have set up right here a static IPv4 address. So here is the ONT that were provided, a Dasan H646GM-V. So in order to proceed with the replacement, we will need to clone all the information of your originals or this one. We need to get serial numbers and then MAC address, software version, hardware version. We need to collect as much as information as possible. So let's say if we go to status and device information, you can see that we have the model, we have the software version, we have the GPON serial number, we have the system MAC address, and if we scroll down, we can see that it's currently VLAN 35. And let's see, so this is the PON status, and we have the OLT type is ZTE. So I believe those information should be sufficient to replace or to clone to the new XRP module. And before we proceed, let's check out the speed test and see what kind of speed we get. Right now, the Dasan H646GM-V is working in bridge mode, and the NanoPi R6S is handling the PPOE connection. So let me run a speed test and we will check the CPU utilization of the ONT that were in bridge mode. Alright, so we are running at 760 Mbps, and right now it said that the CPU load is just 15%. Is that correct? Let me just refresh the page. Alright, just now it's go to 22%. The CPU load is still at 22%. So for upload, we have around 400 Mbps. Let's refresh the page and let's see if this one is up to date. Alright, so it's just now 30 or 29. So let's run the test again, and this time I will refresh the page to make sure that it shows the correct CPU utilization. Alright, 27, 26, and 25, and we can see that the memory usage is now 70%. Alright, 23. So this is the current CPU utilization at the speed test. So we have more or less around 700 Mbps download and around 500 Mbps upload. It is right now, let's see, 10:39 on Friday, July 28. So before we proceed, I'm going to create a note. I will copy out all the device information so that later on I can clone it to the new XFP GPON module. So let's see, this one is MAC address. So actually you can see that we have something different. So this is the MAC address for the one interface, and this is the MAC address for the GPON device or for the whole router. So they one number different, okay? Now I'm going to disconnect the fiber cable from the Dasan H646GM-V. After that, connect the LEOX LXT-010S-H to the media converter, and then let's connect the fiber cable, connect the power cable, and at the end connect the media converter to the NanoPi R6S in order to configure it. Now, the LEOX XFP is up and running. However, the PPE connection is still down because we have yet to configure the GPON XFP module. In order to reach the LEOX LXT-010S-H with an IP address of 192.168.100.1, we will need to create an interface with static IP address of 192.168.100.5. Set the netmask to 255.255.255.0, assign it to the one firewall zone, and after that we should be able to ping it. Let's check it out. Very good, we have the response from 192.168.100.1. Let's open a new tab and access the web UI. The default login will be LEOX and the password is LeoLabs_7. Here is the web UI of the LEOX LXT-010S-H. Let's check out the PON status. We can see that the ONU state is O2 because the GPON XFP report a different GPON serial number, ONU Model, etc. to the OLT. In order to configure it, let's go to the admin tab and then GPON settings. The LXT-010S-H supports 4 OLT modes: default, Huawei OLT, ZTE OLT, and customized. To take full control of the GPON parameters, I will use the customized mode. However, there are limitations when configuring using the web UI, such as I have to input a dummy PLOAM password and LOID password to save the OLT mode. Also, I cannot change the GPON serial number from the web UI. On the OMCI information tab, there are something we can change such as the vendor ID, software version, hardware versions, etc. I want to change more information than what is showing on the web UI. That's why I will go and configure with the CLI using Telnet. Here we have a detailed user guide for the LXT-010S-H that were repaired by GPON and all the contributors. You can find all sets of commands to change the GPON serial number, GPON ONU ID, hardware version, software version, and OLT mode, etc. Basically, these commands are more or less the same with all the Hisense GPON XFP modules, since it is based on the Hisense LTE3415SH Plus model that is powered by the Realtek RTL9601CI chipset. Let's open PuTTY application and establish the Telnet connection to the GPON XFP module. The login is the same with the web UI, LEOX, and the password is LeoLabs_7. Here is the information of my original GPON router. Let's clone that to the LXT-010S-H. I will start with the GPON OLT mode in order to change all the GPON parameters. The flash program is located in etc scripts. To call it, you can type the full part or simply type the flash command. Let's run flash sets omci_olt_mode space 3 to change the OLT mode to customize. Next is the GPON serial number. To check the current value, we can use flash get GPON_serial number. Here it is. The current values is LEOX G100062. To change it, we can type in flash set GPON_SN followed by the new GPON serial number. Now, let's change the software version with the nv set environment command. And then, let's update the hardware version as well. Next, we will need to update the PON Vendor ID, which usually is the first 4 characters of the GPON serial number. In my case, it is DSNW, stands for Dasan Network. And finally, let's change the GPON ONU model with the flash set GPON_ONU_model. Very good, all is done. Let's restart the XFP GPON module with the reset command. I will ping to check when it is available. Very good, we already see the response. Let's go to the LXT-010S-H web UI and check the authenticate status. Very good, the status is 05, which is successfully authenticated. On the GPON setting, we can see that the serial number has been updated with what we type in. Let's go back to OpenWrt and check the internet connection. Unfortunately, the PoE connection is still down. Let's restart it. Very good, the connection is up and we can see IPv4 and IPv6 IP address from the ISP. Let's have a quick speed test. Cool. The download speed is up to 2129 Mbps and the upload speed is at 415 Mbps. Let's change to another server. This time, the speed is lower but we are running above gigabit rate. Let's have another speed test with the CPU utilization of the R6S. We can see that the R6S handles 2000 Mbps throughput with 25 to 30% CPU load. To make sure the result is accurate, let's have another test. This time, the CPU load is up to 45% with 2150 Mbps. Now, I will check how is the CPU utilization of the LXT-010S-H. We can see that with 2000 Mbps throughput, the CPU load is at 50%. There should be sufficient CPU resources when the GPON link is fully saturated with 2.5 gigabit. So far, we have set up the LXT-010S-H with a 2.5G media converter and the NanoPi R6S. If you are not using OpenWrt, you can directly connect the media converter to the PC and set your network adapter IP address to 192.168.100.5, and you should be able to reach the LXT-010S-H at 192.168.100.1. Besides, please check and change the GPON mode from 2.5G to 1G and vice versa if you encounter any problem with the link speed. Just in case you are using the X-Router X series, you can check out my previous video on how to access the modem or XLP behind that. So that is all for this video. Thanks for watching and see you guys in the next updates.